The derivatives of exponential functions can be solved by these two rules. We have the derivative of a raised to x with respect to x is equal to a raised to x times ln of a. Now here on the second rule, since a here is e, we have e raised to x times ln of e as to follow the first rule, and since ln of e is just equal to 1, that is the reason we have e raised to x as the rule. So let us have the first example. The derivative of 2e raised to x with respect to x is equal to, we separate 2 because that is constant, and we get the derivative of e raised to x, which is itself e raised to x. So the answer is it's 2e raised to x. The second example, the derivative of 4 raised to x plus x is equal to the derivative of 4 raised to x is 4 raised to x ln of 4 as to follow the base here plus 1. So that is the derivative. The next example, the derivative of negative 7 raised to x plus 2x. We start from negative 7 raised to x, and that is negative 7 raised to x ln of 7, and the derivative of 2x is simply 2. So the answer is negative 7 raised to x ln of 7 plus 2. Next example, we have the derivative of negative 9e raised to x minus 4x. We start from negative 9e raised to x, and that is negative 9 times the derivative of e raised to x is itself e raised to x. So we have e raised to x minus 4 raised to x and ln of the base 4, ln of 4. So our answer is negative 9e raised to x minus 4 raised to x ln of 4. The next example follows the rule of product, and we have x, the derivative of x is 1, and the derivative of e raised to x is itself e raised to x. Therefore, we have get the derivative of the first factor, the derivative of the second factor is e raised to x. First factor derivative is 1 times the second factor e raised to x plus the derivative of the second factor e raised to x is itself times the first factor x. So we now have e raised to x plus x e raised to x, and they are factorable, so bring out e raised to x and multiply that to 1 plus x. But then you can have this as your final answer, or you can also have the other. On this next example, we can bring out 3 as the constant and get the derivative of x times 7 raised to x. And x and 7 raised to x is a product, so we use the product rule. The derivative of x is 1, and the derivative of 7 raised to x is 7 raised to x ln of 7. So in our so we get 3, and the derivative of the first term is first factor is 1. Then you have to multiply that to the second factor, 7 raised to x. Then forget the plus, and the derivative of the second factor, 7 raised to x, is 7 raised to x ln of 7, and then you multiply that to the first factor, which is x. So we now have 3 times 7 raised to x plus 7 raised to x ln of 7, and there is x here, so x. So you notice here that on the binomial, we can bring out 7 raised to x. So we have 3 times 7 raised to x times 1 plus x ln of 7. Now we can distribute 3 on the two factors here, or two terms here. Then we have to bring out 7 raised to x. So we have 7 raised to x times 3 times 1 plus x ln of 7. We can now distribute 3, so we have 7 raised to x. 3 times 1 is 3. So 3 times x ln of 7 is 3x ln of 7. So that will be our final answer. On this next example, it is the product of 3 raised to x and 2 raised to x. So we need to get first the derivative of 3 raised to x, and that is 3 raised to x ln of 3. And the derivative of 2 raised to x is 2 raised to x ln of 2. Now we have 3 raised to x as the first factor. Get its derivative, so we have 3 raised to x ln of 3 and multiply that to the second factor, 2 raised to x. Now get the derivative of the second factor, 2 raised to x. We have 2 raised to x ln of 2 and multiply that to the first factor, 3 raised to x. Okay, that is a product rule. Now we distribute, and we can able to notice here that these two terms, they have common factors. So here we see that 3 raised to x and 2 raised to x are common to these two, so we can bring out 3 raised to x and 2 raised to x. So we have 3 raised to x times 2 raised to x. So ln of 3 na lang natira dito, plus ln of 2. ln of 3 and ln of 2, they have the same base, which is base e, and the operation is addition with mean product rule. So we have to simplify. We have 3 raised to x times 2 raised to x. So 3 times 2, you see the product rule is 6, so we have ln of 6. So our answer is 3 raised to x, 2 raised to x, ln of 6. So next is also product rule. So get the derivative of e raised to x, which is itself, and the derivative of 4 raised to x is 4 raised to x ln of 4. Now get the derivative of the first term, first factor e raised to x, which is itself, and multiply that to the second factor, 4 raised to x. Now get the derivative of the second factor, 4 raised to x, which is 4 raised to x ln of 4, times the first factor e raised to x. Now we notice here that e raised to x and 4 raised to x are common to these two terms. Therefore, we factor it out to bring out e raised to x times 4 raised to x. So this is now 1, and the other is ln of 4. So plus ln of 4 when we factor out. Okay, now this is already the answer. So this makes use the quotient rule. So we have to square the denominator, get the derivative of the numerator e raised to x, and that is itself e raised to x, multiply that to the denominator 2 raised to x, minus the derivative of the denominator is 2 raised to x ln of 2 times the numerator e raised to x. We notice here that they have the same factors. We have e raised to x, 2 raised to x, and also e raised to x and 2 raised to x on the second term. So we can bring it down, bring them out. So we have e raised to x times 2 raised to x times 1, because this is good as 1 when you divide it by itself, times ln of 2. So divided by 2 raised to x times 2 raised to x. We can now cancel out 2 raised to x here, and we now have e raised to x times 1 minus ln of 2 over 2 raised to x. So this is our final answer. This is also quotient rule. So 3 raised to x plus 1, its derivative is 3 raised to x ln of 3 plus 1. Okay, so derivative of x here is simply 1. And the derivative of the denominator 5 raised to x is 5 raised to x ln of 5. Now, to have the solution, equate that. Square the denominator of 5 raised to x. The numerator derivative is 3 raised to x, ln of 3 plus 1. Multiply that to the denominator of 5 raised to x, minus the derivative of 5 raised to x, denominator, times the numerator 3 raised to x plus x. Okay, we may now distribute. So we have as well, we can also observe that we can bring out here 5 raised to x because they are common to these two terms. Why do I mean two terms? Because they are grouped as 2. Okay, they are considered to be two terms. Okay, they have the same factor. Bring out 5 raised to x would mean this will be 5 raised to x already. So we already simplified, so we have 3 raised to x, ln of 3 plus 1 minus ln of 5 times 3 raised to x plus x over 5 raised to x. Okay, so we now have 3 raised to x, ln of 3 plus 1. So distribute ln of 5, so we have 3 raised to x, ln of 5 minus, okay, minus x ln of 5 over 5 raised to x. So here we can bring out 1 and combine this with the same 3 raised to x. Okay, so we have 3 raised to x times ln of 3 minus ln of 5 plus 1 minus x ln of 5 over 5 raised to x. Okay, so we now have this final answer. Actually, you can have this as your answer. It is already accepted, but this can be more simplified. So we have this, our final answer. There are also cases wherein you are asked to evaluate using the derivatives. For example, you have f raised to x is equal to e raised to x, 2 raised to x, and then you are asked to get f prime of 2. So to do this, we need to find first f prime of x. So we need to solve f prime of x. So we have f prime of x is equal to the derivative of the first factor e raised to x itself times the second factor 2 raised to x minus the derivative of the second factor 2 raised to x is 2 raised to x ln of 2 times the first factor e raised to x. This must be plus because we are into product rule. Okay, so we have f prime of x is equal to e raised to x times 2 raised to x times 1 plus ln of 2. Okay, so this will be the derivative. Now to solve for f prime of 2, just simply substitute x equal to 2. So that will now be e raised to 2, 2 raised to 2 times 1 plus ln of 2. So the answer is 4e squared times 1 plus ln of 2. This is the final answer. Another, let's say g of x is equal to x times 10 raised to x, and you are going to find g prime of negative 1. So how do we get this? First, we need to get g prime of x, or the derivative of g, and still this is quotient rule, product rule. So we get the derivative of the first factor x, and that is simply 1. Multiply that to the second factor 10 raised to x plus, okay, we're now looking for g prime of x here, plus the derivative of the second factor 10 raised to x is 10 raised to x ln of 10 times the first factor x. So we now have 1 times 10 raised to x is 10 raised to x plus 10 raised to x ln of 10. So you can have x times 10 raised to x times ln of 10. So here we can bring out 10x, 10 raised to x, factor it out. So we have 10 raised to x plus 1 or times 1 plus x ln of 10. So this will be our final answer. Now, to find for g prime of -1, we can just simply use this derivative of x of g. So we have g prime of -1 is equal to 10 raised to -1 times 1 plus -1 times ln of 10. So we now have 1 over 10 times 1 minus ln of 10. Or you can write that into 1 minus ln of 10 over 10. That is the final answer. Take note that you're not going to divide 10 and 10 and you have 1. No. That is a mortal sin in logarithms. So this will just be the final and that is simplified answer.